Okay, so we have people joining us here. I'm gonna give them a minute or two before we start. So we already have around 20 people live here with us.
That's great. Can't wait to start.
Okay, it looks like everyone who was waiting joined now. The number is not changing much, so I guess we can start little by little. So hello everyone, and welcome to the first Vilnius Golang meetup online. Today we have Rokas Bilevičius from CAST.AI, and he's going to tell us about our journey with Go. We will have a QA session afterwards, but you can post your questions at any time using Zoom features, and I'm gonna keep track of them and just ask Rokas afterwards. One more thing before we begin, I'd like to ask for potential speakers. So if you wanna give a presentation in the next meetup, please contact me. Okay, so without further ado, let's hear from Rokas.
Okay. Oh, first thing, I cannot share my screen. Could you make me not as a regular participant?
Yeah, okay, we have to do that, I guess. Yes, the meeting will be recorded, so if you have to drop off early, you will be able to find a recording of this event in a couple days. Okay, Rokas, try it now.
Now it's fine. All right. So you should be able to see my screen. Let me know my slides. Let me know if you don't.
It's looking good now,
yeah.
Rokas.
So as Pranas mentioned, I'm Rokas Bilevičius. I'm a software engineer. Throughout my career, worked mostly on infrastructure projects like databases, operating systems, ad hoc enterprise systems, monitoring, bit of blockchain in between. And for last few years, my best friends are Go and Kubernetes, I would say. But in all fairness, deep in my heart, I'm just a simple geek, thrill seeker, and a father of two. But today is not a talk about me, so let's move to the real deal. So around a bit more than a year ago, I got an invitation to join a ambitious and challenging project in a startup CAST.AI, who is based here in Vilnius. Its goal was to create a multi-cloud platform, which would give you a Kubernetes cluster, which would run on several clouds simultaneously. So you would use several cloud providers with just one cluster. So you would be able to access all the resources from all the providers you use in one cluster. So the problem is hard, believe me. But we had, when we started, we had a clean sheet of paper. I guess it's a dream of most engineers to get that. But on the other hand, it's exciting, but not as trivial as you might think, as you have to go through lots of discussions, decisions, how would you do things even before you start doing anything. So I guess that's the main thing that I want to give to you, that after this talk you would know, at least in high level, through what things we went, what decisions we had to make, why did we make them, and where did we end up after a year from that clean sheet of paper. So I will start from talking about culture at first, as I think it's important not just what you do, but how you do it. Then we'll move to architecture. We'll explain what pragmatic choices we had to make to move faster. Also, we'll talk about operations and things regarding that, how we handle them. Also, we'll talk about tooling, testing. Testing. Last but not least, the testing part. So let's kick off. And you think we came to a Golang meetup, but I didn't hear anything about Golang. So that was the only thing decided for us before I joined. Go really fits well into infrastructure projects. It's simple, fast, has a native concurrency model, and all other nice things we love Go for. So yeah, let's talk about how we did it. As I said, it matters as much how we do it, and I cannot efface too much to my colleagues, which I have, because what we achieved in a year and what we have built is first of all achievement of people, and if you want to move fast and build amazing things, they do not just spawn from existence. You need a good team, and basically my point being that choose your colleagues wisely, as that's the foundation you'll have to the project you'll be working on. So throughout that year, we adjusted to several commons in our engineering department, the way we do things, and how we reach decisions. So I will go through several highlights of our culture. So this one came quite naturally. I guess it's mostly because of the nature of people, and our HR department made a good job by fitting everyone in a similar cultural level, and that we can communicate well. So basically, every decision we make, everything starts from a discussion. Everybody presents their ideas, and there isn't that someone's idea has a higher weight than others. Usually, it's just the best idea wins. And we approached that, for example, like if we want to select some tool which we would use, we would make investigations and like test several tools. For example, the one of the deployment tools we chose, and when we make a presentation to the whole team, several of us who did that, and when we would vote, like like in a democratic country, and there's a saying that democracy is the easiest way to ignore the minority, but usually and quite often our decisions were unanimous. So let's move to the next one. We have a CTO who's a very technical person. It's not his first and not his second startup, and he started a lot of many years back and had a lot of hands-on experience, and consequently he has a strong opinion about technical things. But that's not the coolest part of having a CTO like that. The coolest part is that he's very open to new ideas, and he encourages people to suggest how we should do it. He basically draws us a vision, what he thinks would make sense in the market. And when we have those weekly meetings with him and the whole engineering team, and we discuss various topics, technical topics, and everybody is welcome to bring his own idea, what he would think would suit our product, as our product is quite technical. So we could say it's built by developers for developers, as most of who will use us will be developing something. So yeah, it's a very bottom-up approach here, and I feel really empowered to make that an impact I can in this company. Also, I would like to mention that we have a good collaboration between teams. Like, we started purely engineers. I was a third one hired, and we expanded bit by bit. And just afterwards, we started hiring UX, marketing, customer support, and so on. And we really invested time on getting them up to speed and explaining what we are doing here, and giving a good input from engineering department, and likewise we are giving their ideas and their feedback. So it's really important to have this in a company, so we could reach that one common goal. Sprint demos, I guess a lot of you who have joined here are doing those, but we started them even before we had customers or something similar. We would just have 2-week sprint and focus on some goals which we think makes the most sense at the time, and deliver something tangible which we could demo and build bit by bit on that. Also, we have this, how I would call them, rituals in our daily lives. So code wars sounds fun, no? What it actually means is that we have a dedicated meeting just for developers to discuss the way how we develop, how we test, and just things that not necessarily relate to some feature, but to the way we work every day, and we try to find and improve things bit by bit. PR reviews, this is of course as sprint demos quite trivial, but what I wanted to highlight that we try not to, be picky or nitpicking on not important things. Usually we have just a rule of at least one peer has to review your work, and if we have some small comments, we just approve a PR and move on. Leave the decision to the owner of the code to decide if it's worth enough. Also, we have a tech decisions channel in Slack. So if we have some discussion about how we should handle date field in our API, or how we deploy code, we just, if we make a decision, just write I want to one or two sentences and post in that channel. And if somebody joins or to the company or haven't been able to participate in that discussion, he would see what has been decided. Also, sprint retros, that's quite common. What wanted to highlight, it came to through the evolution of the ones we had. Currently, what works for us is we have interactive board in Miro. Not sure if you heard it, but you can Google it up. And we just give 10-15 minutes for everybody to fill up what they feel and so on. And then we go through those items, decide if we need to take any action on it, make those action points, and every retro we can come back to if they were completed or not. And so that meeting would not be just swearing about things you don't like, but actually improving something. All right, so enough of the soft things. Let me have some water. Now let's move to the next part of the talk. I guess this is more exciting one, which you want all to hear. So here I will focus on several high-level topics which you need to choose when starting a project. And I guess these ones were the most impacting our systems architecture. So first of all, the classic one, should we do the microservices monolith or something in between, and how should we do it? There are pros and cons. I guess most of you know, but a microservice is a small service which would have just sole purpose, would be autonomous, testable, and uncoupled from other services. Compared to the monolith, where all your functions work in one executable, and you write code in one place, everything coupled, and so on. So to not get very deep into the technicalities, there are lots of material regarding this online. I will just say what we decided. There are a couple of opinions in a team. Some of the opinions wanted to do monolith first and then look how to break it out. myself, I had experience working with microservices and didn't want to go back. So we made quite in some cases, one approach, in some other. So it's a bit of a hybrid. So for example, we have a microservice to store customer cloud credentials, cloud keys. So it's fully autonomous with one dependency of SaaS provider where the real storage of secrets, as we do not handle them and offload all the sensitive stuff to a certified provider. We just use the service to manage that and save the metadata we need. And so that's a pure microservice. And for example, we have some other microservice, which is, I would say, a sandwich of two. So we have a provisioner service, which has an API, which basically is a CRUD for creating clusters, Kubernetes clusters. And that's the one part of a sandwich. And the other part is a worker pattern-based scheduler, which runs a reconcile loop to actually provision those clusters in cloud providers. So it runs on one service. And it is synchronized. Those two layers are synchronized with filling of database. So the CRUD part threads writes to the database, and the worker part sees the updates are woken up by the calls and creates the clusters. And also you can see a graph here that the green and the red, I guess you can, more experienced guys can guess what's green and what's red. So red is monolith, green is microservices. So you get overhead at first when starting with microservices, as you have to duplicate a lot of boilerplate, how to start the service and so on. But once your functionality grows, it gives benefits. So it makes sense just to start with a monolith, maybe, if you don't see the benefit at the get-go, and then break them up. So for the provisioner example, we could break that up at the point we would see the benefit of scaling it differently, the CRUD part and the provisioning. But for now it works, and we'll improve if we need. So now we have all those microservices. We need to decide how we will communicate. So a classic battle between MQ and point-to-point. I was a huge advocate for message queue, but there were other opinions. And at first we started just with point-to-point connections where we aren't too many microservices, and it's much easier, to debug. There is less overhead of maintenance of that messaging system. Also, you need to ensure handling of the events in the message queue, deduplication, lost events, and so on. So it's better to start with point-to-point, I would say, and especially if an action you need to do in one microservice needs to trigger just one other microservice. But as the time went past and we saw the benefits where message queue would bring, that message queue would bring to us, we introduced that. And so we use both right now. So for example, if we have an event happening in one service, which needs to know several different services, we just push an event And if it's just one service needs to inform other service or get it for something from it, we just use point to point. So just being pragmatic of what you need. Moving along, so talking about contracts. At first, we had a lot of discussions what tech stack we should use. Should be REST or be the cool new guys in the park and use gRPC like Google. They use gRPC enriched with REST endpoints. So we do not have any purely REST anymore. So we decided to do a hybrid again. To the outside, we have a gateway for the API, which is purely REST. But inside our tech stack, we everywhere use gRPC. It's faster, more backwards compatible, and I would say it's a good step up. But we chose to leave the rest for the public, as most of the people and the most of the companies around the world is still on REST, and it wouldn't be a good example to not support that. Inside the team, we developed a habit to develop in contract first way. Like if you have some functionality which would touch some API contracts, REST or gRPC, we write the contract, review it, everybody's happy with it, and just afterwards we just implement those APIs and everything works. We had a lot of discussions how to make the RESTful endpoints user-friendly, and we spent a lot of time when I think back right now on discussing that. And once we got to the point that we all agree on the style and we like the way we do it, the work just goes butter smooth, and we do not need to go back to that anymore. And also we use those contracts sharing between teams. So it's a golden source of truth saved in one place. So we do not copy it from one place to another. We just have one place for all the contracts. Moving on to the shared code. So we have a lot of microservices. We need to start them up. And basically they need same things: monitoring, logging, and database initialization, and starting the server, and so on. So we felt that we copy a lot of boilerplate. There were discussions, maybe we should write some custom framework, like how to start a service, but that's a good rabbit hole to start, as you'll have to support several different things in the long run. Then you want to change one thing in one service, you need to modify it, changes things in all services, and it's just another thing to maintain. And Golang, in my opinion, is I don't like frameworks in Go. I like a standard lib, and try to work around with that if I can. So we decided that we'll create just small shared libraries between the microservices. So for example, I want to start a microservice, I'll have some shared method, shared lib, which would initialize logging, another method for tracing, some cloud functions, and so on. and that went real great for us. Okay, so next session about operations. That will be all for the architecture part. And I like to emphasize that we invested a lot of time when starting developing into the operational things, like building the monitoring stack, logging, automating CI/CD, and so on. So there is a good book regarding what we, which I read after we started, and the main takeaway I took from it that you should never stop improving, and that good teams from bad teams differ in that operational speed, that automating that monotonous deployments or testing and so on improves the way the team works, and we can focus mainly on developing features. And it also improves not the velocity, and you would feel that maybe safety suffers because of higher velocity, but the opposite is true, because there is less human interaction and more automation, which brings benefits. And those gaps between good and bad teams, they just grow. Like similarly, like I guess the universe expands, the gap gets bigger going time forward. So make sure you're in the right galaxy in the future. So let's move through some points I want to mention about operations. So the observability part, the three pillars, like, logs, metrics, tracing. We started with the tools everybody was familiar with, Elastic Stack, Prometheus, and Jaeger. And we were quite happy with that, but as we tend to improve all the time, we found a way how to improve here as well. So Elastic raised a lot of maintenance issues for us. We do not have dedicated operation persons. All engineers, all developers do their part, and we maintain our operations by ourselves. So we like things to run smoothly and with as least intervention we need, we can give. That's a bit better. So we moved from Elastic to Loki from the Grafana developers. And we even found a plugin for Grafana to incorporate tracing as well, called Tempo. So now we have one interface for everything, for logs, for metrics, and tracing in everything in Grafana. And before we had to go to 3 different places. So it made investigations and debugging much faster and easier for us. Also, for CI/CD automation, we started in GitHub. At the time, we released the reactions, and for CI part, it was all right. But later, we moved to GitLab. But all the time, we put effort that all the CI/CD operations would be done automatically. And I will get back to that in the next slide a bit. So we worked with monorepo approach. All our microservices, everything is in one repository. So It has its benefits if you want to deliver a feature which spans through several services, you just raise one PR. You don't need to juggle which one I should deploy first. So once you merge the code, one commit is one deployment, and the feature goes into the environments. We didn't have experience before using monorepo, but we tried it and it stuck to our project, and we wouldn't go back regarding that. So I said I'll mention about our evolution of CI/CD. So as I mentioned, we started in GitHub, migrated to GitLab, and GitLab has a very good functionality. It's really powerful. Its DevOps engine is good, and we could do a lot of nice things there, but it's really not suitable for monorepo, as your whole automation, all pipelines and all services would run in one project, and our deployments and so on become cumbersome. So in the end, we migrated the CD part to Argo. That's a GitOps way of deploying. So right now it works really nice for us. GitLab just pushes to some repository a commit, a Docker hash, which should be deployed, and it's picked up automatically. So we do not have any manual steps to go to production. After the code is merged, it runs through automated tests, goes to dev environment where end-to-end tests are ran, and if everything passes, it's deployed automatically to production. So we release on every commit to master, and that's been also great for us. And I will come back a bit to that in the testing part, and I'll explain how we ensure that those bad commits don't go to production. So when the customized versus Helm, I used Helm before joining here and really wanted to try out customize. It looked much simpler, but after some time, we bumped into limitations of it. Helm might be more complex, but gives more flexibility as well. So we switched back to Helm. Also, for infrastructure as code, naturally we use Terraform. And just from the get-go, we had guys with lots of Terraform experience, and we didn't click buttons in Cloud Console to create environments for us. We used Terraform that we could replicate those environments, and it's not more about saving time. It's more I think, to be consistent. And let's say you need to recreate an environment, not often, but you won't save a lot of time automating this, but you'll save a lot of time to making those environments the same, as you'll forget what you need to do after a year. So at first we have dev, staging, and production environments, as that was, at least for me, a standard I used before in enterprise environments, and that worked there. But here we felt that staging environment doesn't give us enough value, and it doesn't suit our way of deploying every commit to master, every commit from master to production instantly. So it just increased the deployment times and ran redundant tests and nobody used staging. So we decided to remove that, save some bucks, to go for some team events better than just to have an useful environment. Yeah, so this gopher is really serious, and he makes our company secure. So even before going live, we started practicing on-call procedures. So every developer works on call. We have I have to work on call once in 2 months for a week. He had been woken up a few times, but I think it's a right approach, as before merging and committing, you feel responsibility for yourself and your teammates, and it's not offloading to somebody else in some other department. So it works well, as I said before. In accordance to that, we have an ops duty. So the person who works on the on-call schedules during that week, during the day, he doesn't work on standard sprint features. We have a separate board to improve our operations, so those wouldn't get lost because of, oh, we need to deliver the feature the business asked. So we do not want to drop the ball and improve our operations constantly. So we do that. Currently, we are discussing the war room procedure, and we'll be testing it out soon. So if somebody bad happens, how to have everybody on a call who could help resolve that as soon as possible. And we had several postmortems already. I suggest for everybody to do that. If something happens, just determine to the root cause. 5 whys is a good way to doing that. So it's basically asking questions 5 times why it happened, going to the root cause, and most importantly, make those conclusions why it happened gone, fix them, because if you won't, you'll have the same issue quite soon. So going to the lintering and code style, Go is quite nice of providing standard formatting, Go FMT for the style, and that's one of the things I love Go for. And for lintering, we use GoLint CI or some packaging like that, and we have a common rules, and we check them automatically before merging any code. Make versus Mage, I guess Make is more popular, and in the start there were some initiatives of using Mage, which is basically the same thing, just writing everything in Go, but we got back to Make as it's more simple and does the work we need to do and nothing more. Also, we use every tool we use, like building contracts, lintering, and so on. Every tool is in Docker. So you do not need to set up anything on your laptop. Just install Docker and run some make commands, and new people do not need to spend a lot of time to start coding. We have a rule inside our team that once we have a new joiner, he needs to make his first commit on his first working day. Not sure how many of you have heard about Tilt, but it made our development much more easier. Somebody says that it's next best thing after sliced bread. So what it does, it can recreate an environment we have in production, literally the same on some Kubernetes cluster. in your namespace, for example, and we set it up so it's automatically exposed to the internet, and you can write code and test it, have a test environment really easily. It's very useful because you do not need to start everything on your laptop, and even if you would start everything, if it would be in a Kubernetes environment, it's really hard to orchestrate the connections, as we have some backdoors where the cloud VMs should report their statuses and so on. So this really improved our life, developers' life a lot. So recommend of checking this out. Okay, so we came to the last part of the talk. We'll talk about testing. As I guess I suspect you do not push any code that's not tested. So let's move to the details how we do it. So our product is high criticality, and I guess everybody who is developing something says his product is critical for somebody, but in all fairness, our production is a base for other people's production systems. So we really need to make sure we work correctly. As some issues in our production could be issues for hundreds of other products. Also, our product is integration heavy. It depends on cloud service providers. We call a lot of their APIs to test, and to test that, it's quite slow and expensive. It's not like calling simple endpoint, which just gives you a response. You have to wait for that resource to be created. And it's a chain of many variables, and it takes some time to juggle that around. So we had a lot of discussions and tried out different things. Should we mock the cloud providers and write unit tests, or maybe those unit tests doesn't make sense? How we can ensure that those mocks are in line all the time? If something changes in the cloud, that means our mock may be out of date. So it's really a hard problem for us, and I do not feel that we have solved it entirely yet, but we try to improve bit by bit, and I believe that we'll get to that point where we want to be at some point at some time. So let's go a bit through evolution, how we are going through that. So we did just unit tests with mocks. Then we put some integrations on that. But you're testing some, for example, create a VM, but to create a cluster from raw resources and networking part, you need a lot more than just to test one method in your code if that's working with a cloud provider. So as I mentioned before, I'll get back to how we test before deploying to prod. So I guess our black box end-to-end tests are the savior, not to having too many postmortems, as it caught quite many things we didn't catch in our unit tests. And basically what it does, it tests our product as a black box, from outside. It calls our APIs and tests that our functionality works end to end. The negative thing being that it takes a lot of time. For example, to create a cluster with Azure VPNs, to start even a VPN connection in Azure takes around 30 minutes. So having few of those cycles in the deployment loop creates a lot of overhead for us. And if we would like to have a quick fix deployed to production, that would hurt. So we started to introduce integration tests back again, but them testing just the communication between components and not the heavy ones. We still use the end-to-end tests, but we are thinking of making a POC for mocking again. So, but right now we are thinking not just to use some standard Go mock libraries from Go, but to write our own mocks, which would substitute the endpoints of the cloud provider servers and return what we want them to return. So, as I said, we're getting there, but in our use case, end-to-end tests are the savior. So that will be all for the testing. And we're at the end of the presentation. I guess the main conclusion from what I would say that not everything works for everyone, and we invested a lot of time and discussed a lot of things to find what works for us. Maybe for some of you, some of these advices will suit you, and it's really great to see that over 40 people was interested in this topic, and good luck for you to use these advices in your future products.
Thank you, Rokas. We are also having quite a few questions, so hope you still have enough energy to continue with this and then respond to all the people here.
Of course, let's do it.
So I'm just gonna go through in no particular order. Well, I'll start to go in the order they were posted, but we'll see how many we can do. So the first one would be regarding your PR reviews. Do you think your style with PR reviews would work in a team which has engineers of various level of experience, juniors, and etc.? And I think it mostly refers to what you said, that it's up to the pull request owner to actually merge and either do the change or not.
It's not that we always do it, like we just leave comments and approve and it's up to him. It's just for those style things, then, everybody has a different opinion in, for example, naming or just functional programming, or maybe more objective oriented. They are both fine in one case or another. And they work fine as well. So for those style things, we leave for the owner, but of course we do not approve if we feel that there is more efficient way of doing that. And I really like the way that if we have a larger discussion, you should do it like that. We do not battle with words in the PR review. We just go on in some Discord channel and discuss live during the review. And as you mentioned in the comment, yes, I think it's very important, not just, it's important because our team is, we do not have juniors and everybody's quite experienced. And you have to have a good approach and mindset of people to be responsible what we are doing. So yeah, it wouldn't work, I guess, with juniors if we are reckless, and would like, oh, I need to make this ticket because I won't have to say anything in the stand-up tomorrow. I'll just merge it and see what happens. So yeah, that
Okay,
will.
I think that covers it. So okay, going next. By the way, we have like 10 of them, so I don't think we can get like a really deep dive into each one of them. But let's see. The other one, which message queue services you are using? Did you try other? And do you have comments on what worked or not?
Yeah, good question. I wanted to mention that before the talk, but that slipped it out, left it out. So we are using Nats. Uh, I had experience with Kafka before, but you need a, a whole team to operate Kafka, and it's really powerful, but we do not need that functionality, what it brings to us. So we chose the more pragmatic and like simple approach with Nats. We had developers with good experience with it, and there wasn't even a question, should we choose something else? Because it covers everything we need. It's simple and fast. So why
So
bother?
you found the Nats to be a lot easier to
It's more
maintain.
lightweight, more lightweight. We didn't face any maintenance issues up to now, so we'll see what the future will bring.
Cool. Okay, going next. So, can you deep into how you share API contracts? How do you store them? How are they accessed, and in what format for REST, for example? And there's also another related question on contracts. Did you use Pact? Yeah, so I'm not really sure.
Yeah. So first of all,
Answer.
we have a monorepo for all the services, and we have a separate uh, folder package for contracts. Uh, so for REST, we use Open API standard, generate the YAML, which then is used by Echo framework for the API part. Um, so you write a YAML in Open API, it generates all the files. Everything is automated, and you just need to run a make command. And the same for gRPC. Once it's being automatically generated, and we import them as proto files for generated for Go. And no, we didn't
Okay.
use the tool you mentioned. I'm not familiar with it.
Okay, so if you're not using any frameworks like you mentioned, but still have many or multiple microservices, what's your experiencing in distributing common changes required for all of them, like some common tracing, common logging, and so on?
So I just, in my previous answer, caught myself that we are using Echo framework but that's for the API part. And as you mentioned, I covered this a bit in the talk. We use small shared libs. We have we have contracts folder, we have libs folder, which is, the naming is not the best one, but inside we have different packages, which are have specific use cases for logging, monitoring, and other shared things. And you just import that package in all your microservices in our CI, for example, this dependency is marked as if anything changes in this shared library, we have to rebuild all the services that use them. So it's simple. You just change the lib and all the services start using it because of automated CI.
Okay, kind of related question was, so you mentioned that one commit becomes one deployment, but how do you deal with synchronizing the way changes are deployed? Like there are dependencies from one service to another, so one needs to be deployed first, and how do you deal with that?
All the microservices currently are in pair of two. We might increase the count if we would need more, but we are being deployed at this. If few services changes, like the mentioned provisioner and cloud credentials, they both change for the same feature. They are being deployed one by one, and the new code would start like at the same time. There might be a short difference, but in time, but there wouldn't be that the service is down, as we have several replicas up, and we try if the changes change breaking, like it has breaking changes. We code the backwards compatibility into the code, so try to have API contracts without breaking changes. gRPC helps a lot in that. And also the code, if we handle both cases, if we see that will be a breaking change.
Cool. Okay, so a few more, I guess. Yeah. So you mentioned that every developer is also responsible for operational things like CI/CD, observability, and etc. And do you think this mindset could be applied to many companies, or is it more of a niche approach and requires certain kind of people and certain kind of project. And on a related note, I think we can also merge this other question and where your postmortems related to continuous delivery. So kind of both continuous delivery related.
So yeah, it requires first we decided to do that. Not just that one person thought about it. No, we won't hire any more people. You all have to do operational thing. No, it wasn't like that. So half of the engineers would be left by now if that would be in that way. But we had a discussion. Everybody was fine with that, and we went with it. Yeah, in different team, different environment, that may not work. And for us, I feel that there are new people coming with different expertise, and you won't be able to have everyone participating at the same level. Not everybody has the same skills. So I feel that when we will grow to a larger team, we may shift to our approach to have operational people. But up until now, it works fine. And for the postmortems, yeah, we had it. We had the postmortems because of that, and we identified the issues, some unsynchronized deployments of a few services. Like we have several teams, but we have one gateway, so it's a bit tricky if uh, one team's tests do not pass, another team is deploying something, and we have shared component. So we had issues because of that, and in all fairness, we didn't fix it yet.
So kind of continuing on this continuous delivery, a couple more questions. So how do you get to production? You mentioned you have dev and then production. So how the code goes from dev to production? Is there a manual step involved? And also, how many times do you deploy a day? Like, what's the scale of your deployments?
So no, there is zero manual steps, and I'm really proud of that and really like that. We built a custom tool which runs as a container inside our deployment flow. Uh, I, I won't go into the details of Argo CD, but it has some scheduling involved. If all the deployments, all the tests were successful, it starts the container with our tool. That tool gathers all the information and it just updates the production repository, which is monitored by the same Argo. So we have two GitOps repositories. Master, when we merge to master, the GitLab CI updates the development branch of GitOps. When all the tests pass in development, that our custom tool updates the production GitOps repository, which is watched by the same Argo CD. And when that gets deployed to production. Yeah, for the number of commits, well, usually it's like 5, 6, 8. Sometimes it's 2, 3, but it's rolling. It's rolling. You know, we are not a that large
Apparently, this
team.
deployment. Apparently, this the deployment topic got quite a lot of interest, and we have some more questions on that. So, do you use some storage databases in your solutions? And if so, how automatic deployments work with those solutions? Like, how do you deal with migrations and so on?
Okay, so we use Postgres in all our microservices, but we use SaaS service to handle the operational part of Postgres. And all migrations are done by every microservice has its own database in the large database. Every microservice is responsible of doing the migrations when it is starting up. So we bake in the migration code in the commit itself.
And if you have to synchronize it, like if there's a migration that's uh, backwards incompatible, how do you deal with our long running migration that's maybe adding indexes for 2 hours? So how do you deal with that?
Uh, we didn't have an issue to do a migration for several hours. I guess we are too small yet to have these problems. Not we have a records of thousands, not millions. Uh, and for the backwards compatible, uh, well, for most of the cases, we are able to write migration files which would update or create new fields and so on, which would be compatible with the new change. Before we went live and we had just internal users, and so we didn't need to do backwards compatibility at first. So we were just pragmatic. We'll deal with these problems when we will have to solve them. But right now we are uh, solving migration SQL files, and that works fine. I would see that the issue would be if you would like to roll back in case of some issue, and if you don't want to make a forward fix, you want just to quickly roll back and the deployment, that might cause an issue. And at these points, just forward fix would fix that.
Okay. One question regarding your on a call duty. So, do you get paid extra for being on a call during the night, and how these things work in your company?
Yeah, of course, we get the additional payment, but that's a standard thing, like the common law in work law in Lithuania. You could check the percentages, what get extra we get in legislation, which is publicly available.
There was also a question, or you can take some days off as a compensation. Is that an option, maybe?
And no, it's mostly extra payment every month by the rules.
Okay. Yeah, some new questions came up, but we are almost there. Let's see. So, what was the main pain point with the Elastic ELK stack, and that made you switch to Locky? Can you explain a bit more on that?
Yeah, the pain point was storage. The logs would grow larger and indexes would become slow, and it constantly required attention from developers. And we thought we'll just POC Loki. One developer suggested that it's lightweight and it doesn't need a lot of maintenance and so on. And we just did a POC. Everybody liked it. We switched to it. It costs less and it covers our needs.
Yeah, I personally have very good experience with Locky as well, and can just recommend it to everybody. It's a lot simpler, and integration with Grafana is very
Yeah.
nice.
That's I guess for me it's the biggest selling point. I have Prometheus, Jaeger traces, and Locky logs in one dashboard, and I can create uh, complete solutions to monitor the system in one view. I do not need to hop from one place to another.
Okay. Yeah, regarding your hybrid approach with point-to-point calls versus event bus, we have a question on that. And so you implement point-to-point communication between two services. And how do you approach when you need to add a second service in that chain? Do you just straight away migrate to queue, or there's like, how do you approach these situations?
I guess uh, we have, every scenario is unique, and we weight it differently, scenario by scenario. And usually, if you decide that one service needs information from other service, or it needs to expose some information to one service, up until now it was right from the get-go. You know that it just will be needed by that one service. And for example, for audit events, uh, right now we knew that just one service needs that information. Uh, but also we understood that in advance we need to make it as an event, because new services might be interested in the same kind of information. So we went to the events instantly, but there were, I do not recall very clearly right now, but I feel that we just changed the code that we emit event instead of exposing the API. So
Did you ever revert back from, did you find places where event bus didn't work as well and you had to switch back to point to point?
not until now in this project now.
Okay, and a couple of simple ones. I guess that's about it.
I could add regarding the events, like it requires more work to handle those in the listening services, and it's harder to maintain and ensure that we work as we should. So uh, you have to weigh if not just do events because of doing events, but also be in balance, not to have a web of straight point-to-point communications, and that's also that influence comes from how many microservices you have. So don't build too many as well.
And I think we have a few simple ones. So can you comment on the scale at your company? How many engineers, what different roles you have, and how long you've been working on this?
So we started a year and a bit ago. So like in 2019, at the end of 2019. Right now we have around 15 or maybe 12 or 14 developers, I, something like that. And with all the marketing, customer support, and so on, we're 25 or so, plus minus.
And do you have any different roles for developers? No, like I think you already mentioned you don't have yet any ops people. Do you have dedicated testing people?
Now well, our director of engineering declared himself as Q&A of a product, but we write automatic tests and build everything into end-to-end. Also, our owners and managers are very passionate about this product. They try it a lot. Customer service also tries. We're not that big to cover it more, and we I feel that we cover everything we need right now. And regarding juniors, we do not have juniors. We have two teams focusing on different parts of a product. One is for core product, like creating all the resources, creating the cluster, and managing the infrastructure. And the other team is the cost optimization, which builds smart solutions for how to save money for people and how to optimize their clusters, like uh, to see what workloads they have, to delete or upscale their cluster if needed, and to so that the cluster would fit their use case as a glove and we wouldn't overspend and have enough performance.
Okay, and are you using your own product for production? So are you at a stage where your product deploys itself?
No, we are not in that inception level yet. We are not dog fooding as much, but we talked a lot about it, and there is the question had an answer to itself, because it's quite an inception problem, how chicken and egg problem. How do you start our production if there is no production yet? So uh, we as we started safe, and we didn't went from that state yet. But for some parts of our product which is not directly linked to the provisioning part, like for the benchmarking, which calculates the performance of the instances in the cloud providers, so that's like the coupled system, and we run it on our own.
Cool. And this is the last question, and it's a bit different one. So uh, yeah, it's I'm gonna just read it here. Hello from California. This is my first time. I'm new here. Personally, what's the best part about the Golang programming language and why? So that's a broad question,
Awesome.
just for a personal question for you.
I guess the most awesome thing is that somebody from California joined the snowy Vilnius in the middle of winter. But for me, I guess it's the simplicity and like not overcomplicated uh, design of it. It's it's for some it feels not as sophisticated. I came from Java to Go, and in Java there are so many constructs, and the mental load is such high uh, to choose which how should I do this. And in Go, everything is simple, and I guess simplicity for me. But I could add so many more things. Speed, like having a binary which just runs on architecture. You don't need to have any dependency. So the list goes on. I when I started using it, fell in love with it.
Cool. Well, that was it. Thank you, Rokas, for giving us this presentation. Yeah, I'm gonna ask people again. We have still about 30 people tuned in, so maybe somebody else wants to do the same and share with the community about their Go journey, share some tips and tricks and whatnot. So please contact me, and we can schedule something. Yeah, the recording should be available fairly soon in the next couple of days. And thank you all for being here and listening. Thank you, Rokas, again for doing the presentation.
Good luck for everyone.
Okay, bye bye.
Bye.